Hello my dear students, so welcome back once again to P block elements. We are talking about group 17. Yes, group 17 we were talking about the chemical properties, in which we talked about the hydrides and then we talked about the oxides. Oxides are particularly for chlorine, bromine and iodine, and basically fluorides are of fluorine with oxygen reaction. So please take care of this. This is very important. We've also talked about the general trends of hydrides and their reasons in the consecutive previous groups. Yes, moving ahead, we talk about basically the reaction with metals. Very simply, I'll take only two group metals, that is nothing but group 1 metal M, group 2 metal E, right? So metal M with X2 reaction will form MX, and group 2 with X2 the reaction will be EX2. Both of these, they are known as metal halides, right? So depending on the oxidation state of metal, basically your metal halides formation will happen. Important is not this reaction. What is important over here are the points that I'm going to give you for the reaction with metals. The first point basically is asked about commenting the ionic or the covalent character, right? Basically, let's say metal halide, one particular metal, let's say sodium, we take example of sodium. So sodium, sodium fluoride, sodium chloride, sodium bromide and sodium iodide. It basically asks you that amongst these which is most ionic and which is most covalent. So I would say that this over here is most ionic in nature, sodium fluoride, and sodium iodide is the most covalent in nature. This is the covalent part, right? Again, I don't need to explain Fajan rule, which says that larger basically, larger anion size, more polarizability, and if more is the polarizability, then covalent character is high, right? So one particular point you need to remember, that for a particular metal and the changing halide ions, larger the halide ion, more will be the covalent character. Then in the same point, it sometimes asks you, like if there is a metal which can show variable oxidation state like Sn, so it shows tin chloride SnCl4 and there is tin chloride like SnCl2. So it asks that among the chlorides of tin, which is more ionic and which is more covalent. So again, the answer is SnCl4 is more covalent and SnCl2 is more ionic. Very simple reason. Again, higher charge on cation, more is the polarizing power. Again, Fajan rule is the answer. More is the polarizing power, and more polarizing power means more covalent character. Hence, +4 state will have more covalent character and +2 will have lesser covalent character, right? So what you need to remember over here is that in this case, in case number 2, you will just remember that halides of metal halides, in which the metal which has the higher oxidation state will have more covalent character and which has lower oxidation state will have lesser covalent character. That's simple, very easy, very easy reaction, right? Reaction with metals, and this is something where the questions will be made from, right? मेटल हैलाइड्स दे दिए जाएंगे और बोला जाएगा आयनिक और कोवलेंट कैरेक्टर के ऊपर कमेंट करो. So just do that and you are good to go with this. Just simply remember Fajan's rule. Yes, so that's all with the reaction with metals. Moving ahead, we talk about the reaction with halogens. Basically, halogen reacting with it, another halogen atom, right? So over here, we will have to basically differentiate. So what I'll do is I will mark one as X and the other as X dash, where what is X? X is basically the larger atom, larger halogen atom, and X dash is the smaller halogen atom. Okay, smaller and more electronegative, larger and less electronegative. Yes, that is what you need to keep in mind, right? So XX dash. Now there is very peculiar thing that you need to basically understand is that since this X dash over here is going to be more electronegative, so the X atom over here, that is, which is larger and lesser electronegative, is going to show the positive oxidation state. And the positive oxidation states can be +1, +3, +5 and +7, right? And over here this is only going to show one oxidation state, that is -1. So once you start cross multiplying, you will see the forms over here. The first form will be XX dash, right? The second form over here will be X dash 3, right? The smaller one 3 atoms and the larger ones 1 atom. Then you have X dash 5 and then you have X dash 7. So these are the forms of interhalogen compounds. These are the interhalogen compounds, the forms of interhalogen compounds which are possible. Correct? Very simple, very easy. Now you need to understand that all these forms will be not possible for all the halogen atoms, right? So what I have done over here is I have just made a small table where what I am going to give you is that XX dash will be formed by these particular elements, XX dash 3 will be formed by these particular elements, XX dash 5 will be formed this, and XX dash 7 is only one, existence is only one, and that is nothing but IF7. Alright. So you need to please take care of this, that all the halogen atoms will not be able to form all the basically interhalogen compounds. And I think the reason for that, the reason basically for this is basically steric hindrance, right? We have understood what is steric hindrance. The central atom and the surrounding atom's size should be, it should be either vast difference in which it can accommodate the surrounding atoms, right? For example, ClF7, this compound is very unstable. Why? Because chlorine is a small atom and around it you want to arrange fluorine, 7 atoms of fluorine, which is not particularly not possible, right? So that's the reason that basically you will not see +7 oxidation states of this. This is also the reason for the same, the steric hindrance, right? Now what is important over here, nobody is going to ask you that how these interhalogen compounds are formed. If you want to even just make a point out of it, you can just say that when these two are present in equimolar ratios, right? So then you will have the ratio, have the form of XX dash. But when your larger electronegative atom is in excess, smaller atom and the more electronegative atom is in excess, then you can have the form of XX dash 3, XX dash 5 and XX dash 7, right? So when this is in excess, then you will basically be having these 3 forms, but not by all the halogen atoms. The reasons I have given you, because of the steric hindrance, this will not be formed. But what will be asked from this part, that is very important. So let's quickly write down some points of interhalogen compounds, because these are something which is going to be asked, right? First of all, they will be asking you the structure, right? And I think when I have helped you calculate the hybridization, then you will be able to find the geometry and you will be able to find the shape. Very simple. If I have to find out XX dash, so X over here, try and understand, X over here has 7 electrons plus 1 monovalent atom, so 8 by 2, answer 4. So for XX dash, I would just write down over here in the column itself, your hybridization is sp3, your geometry becomes tetrahedral, very important, geometry becomes tetrahedral, but the shape is linear. Why? Because out of 4, only 1 is bonded. Just try and look over here. Only 1 is bonded. Rest 3 of them are having lone pairs in them. So it is basically a AB3L type. ABL3 type, sorry, ABL3 type, 3 lone pairs. So AB is a linear shape. So this is how you will be basically calculating the hybridization of XX-3, XX-5 and XX-7, and also yes, you will calculate the geometries and the shapes and put it in the comment box down below. Yes, alright, and we will be discussing this in your regular class. I'll be discussing this first and then I'll be going ahead. Yes, next point that you need to put, structure is the first point. Next point you need to put is that all the interhalogen compounds, they are basically covalent in nature, right? They are covalent in nature. Next point, they are also diamagnetic. All the electrons are basically all the electrons are paired. Yes, perfect. Very important points here, so please make sure that you write this down. Next point that you need to write down is very important. Put a hashtag star on this point, and the point says that your interhalogen compounds, they are more reactive than basically the halogens. Interhalogen compounds, they are more reactive than the halogens. Why? Reason I'm writing down over here. Reason is that XX- bond is a weaker bond compared to XX bond or X-X bond, right? XX- is a weaker bond compared to XXX or XX-. XX or X-X-, right? That's the reason that interhalogen compounds will be more reactive than the halogens. Perfect, very important. And from here the questions will be asked something like this, that why ICl5 is more reactive than I2. So one simple reason, this, that ICl bond is weaker than II bond, and you can understand this is because of the difference in the size, right? Iodine and iodine, both the atoms are very large, so they will basically compensate each other, right? Whereas or basically they will complement each other, whereas ICl, the atomic sizes is very different, right? Then next point on your screen, that all these interhalogen compounds, this is one of the most important reactions, of group 17 which will be asked. Interhalogen compounds, they undergo hydrolysis. Yes, all these interhalogen compounds, they undergo hydrolysis. And what do they do on giving hydrolysis? I'm writing down over here. So that if there is an XX-, for example, so it reacts with water. Hydrolysis means it reacts with water, right? It reacts with water to give, please try and understand, this is very simple logic. This is H plus and this is OH minus. Yes, so one of the X's over here will react with H plus and one will react with OH minus. So try and remember this trick. X dash, the smaller atom, will react with the smaller ion. Smaller halogen atom will react with smaller ion, that is H plus, and larger will react with larger. And what are they going to form? They are going to form HX and HOX. Yeah, so this is HO and X. Correct? Where this is having a -1 and this is having a positive oxidation state. So negative with positive, negative with positive. Simple. Smaller with smaller. वाटर मॉलिक्यूल को मैंने हमेशा से याद करवाया है, H plus OH minus. Yes. What are these known as? This is very important. Yes, this is known as halide, hydrogen halide. This is known as hydrogen halide. And HOX form is known as hypohalite. Hypohalite. So if there is HOCl, I call it as hypochlorite. Yes, hypochlorite. HOF, hypofluorite. Perfect. So this HOX form is hypohalite form. So all the interhalogen forms, they will react with water to form HX and HOX. Very, very important reaction that I have just given you. And direct question is asked from this part. Yes, direct question. जो ये last point मैंने आपको बोला है. So the forms on your screen, interhalogen, and the points that I have given you about the interhalogen compounds are going to be very, very important. Most important is going to be the structure, because they are more interested into checking whether you know how to calculate the geometry or shape. So please make sure that you write down hybridization, geometry and shape for all these forms. Yes, we will discuss it in the coming class. With that, I end the lecture for this particular part, that is chemical reactivities of group 17 elements. Take care. Bye bye.